Check, check, check. Okay, guys, help me out for a minute. You come with me.
Yeah, maybe. Monkey's fucking football, right? Watch fingers. Okay.
Hey. There's oil inside of that compressor there. If it gets on concrete, it stays forever.
Oh, it smells wonderful. So you told her just a little off the top?
Check, check.
I am sunburned. My brother was doing bits of the last 2 or 3 days. I've been trying to do it. You have 400 or 3?
Morning, sir. Morning.
Darren,
Wait, I don't lock myself off.
probably twice a week.
Who?
Darren, another day.
Calling you today. It didn't call me at all.
I told him to call off.
Well, what time do you schedule? All right.
That's why I was helping out. But if he wants to get out there, he would fix it, change the whole light.
Dennis.
Hey, do you want a scale?
We don't need no scales.
He's got them.
Good morning. Hey, Dwayne, the water softener guy, is gonna be calling in to try to schedule for Pablo. Are we do, we're training this morning, so has he called you yet?
For you? Yes, I think you can see.
Okay.
You need a
He's
scale?
trying to schedule that, so
Yeah,
let's
yeah.
do it in the morning.
Let me just do it.
Yeah, today. I think so. Where do we just, yeah, if he can do that, okay? All right, thanks, bye.
Harold T. Faltermeyer.
Davies for a while,
Just waiting for all you bus to move.
That's not good luck.
Got that alone, I don't care.
I told him to try to schedule if we can attend at 12 today. Right.
Not really, all time.
Just see if he calls in, I just called Lee, told her he calls in, so I see if he can
Mike.
attend at 12 today.
Why did I say Jack Bell?
What's going on? What else you need, Ollie?
Oh, that's it.
Sure is big old hose you got there.
Yeah, it is. Holy smokes.
Thank you for
Same
Must
hardware
be there.
Scott?
his days.
Looks like he's compensating.
Said you got the same hardware ruler, Scott.
Take a ball with a banana in the tailpipe. Why do you look like I just insulted you?
We signed
Yeah.
the paper, just like down there.
All right, you ready to start? Unless you want me to.
Good morning. We are going over to refrigeration today. So we're going over some simple refrigeration charging and equipment. So before we start anything, so you guys know what is blue and what is red, right? What is the blue one? Low side or suction pressure. What is the high side? Liquid or high pressure. Okay? So like we went before, we talked about the compressor right here, how refrigerant works in the compressor. We have two kind of compressor, right? Which one is the rotary? And another one is? Huh? Rotary and the scroll, right? These two type compressor we have. Which one we have the most problem to get reverse? The direction goes different rotation.
Scroll.
Scroll. Why?
Because if you get swept of power, I want to go in reverse.
Because of the voltage, because in the high voltage interruption and the refrigerant. And refrigeration. If you put too much refrigerant in the small compressor, the rotation, it has a lot of pressure behind it. And one interrupt 240 volts, it can reverse that compressor. So refrigeration is always important. how to charge it correctly, and be patient when you're charging it. So you don't want to dump the refrigerant if it's low. I know you just turn the, cylinder upside down and put so much liquid in there, it causes overcharge. When the compressor gets overcharged, it causes a lot of problems. It causes overheating, right? And what else?
Lock it.
Huh?
Lock it.
Like it, high head pressure, right?
I am, Joe.
High head pressure, high amperage, right? It's all because of the overcharging affect the compressor. So 2 weeks ago, I remember we announced the compressor was dead, right? And in just 4 pounds compressor refrigerant, it was only taking 4 pounds. Somebody dumped 11 pounds in there, or 9 pounds, 9 to 11 pounds. And the compressor wouldn't run. They automatically thought it's a bad compressor. I'm glad Mr. Volken went there and got it running. So refrigeration always affect compressor and other component. So we gotta make sure we put the right charge inside the compressor before we do anything. So, any questions so far? How does it work between rotary and scroll compressor? Very quickly, the rotary is the piston, right? So, by winding around, this piston goes around and push the refrigerant here and force the refrigerant, compress the refrigerant back to the system, right? So the scroll, we have the scroll, it's gonna be like that. So the refrigerant is gonna have too much pressure right here and compress the refrigerant back to the system. So that's what we call rotary and a scroll. Only a scroll compressor can be reversed. That's the only different things between two kind of compressor. So it's very important to charge it correctly. So when we hook up our gauge, we want to hook up the gauge to both liquid line and suction line. Every call we go, right? We're not gonna just hook up the suction and we see it's low and put refrigerant in there. So many times there is air in the system or there is a moisture in the system, you don't notice without having the high side in the system. So always connect both gauge, high and low side, to the compressor. And then look at the charge. So 2 different methods of charge we have, right? What is the first one?
Ollie, would you mind using the black?
Yes, sir.
It shows up better.
Yes. So we check the charge on superheat, right? The second method is subcooling. Good job. Only we use these 2 things to adjust the refrigerant, right? So now I'm asking Roy. So when we use the subcooling,
When do we use it?
yes,
I would say TXV, because it's on
TXV.
Yeah, it shows which speed.
So TXV. When we use the subcooling method, you gotta see if we have a TXV in the system. Okay, when we have a superheat, when we have a piston, we use the superheat method, right? So how do you calculate the superheat? Mason?
Superheat is the difference between the saturation temperature at the pressure and the actual temperature on the line. So,
Which,
on the liquid side.
where liquid side?
On the
Suction.
suction side.
Suction side.
Yeah, on the blue side.
Suction
Or,
side,
sorry,
okay.
or gas line.
Suction side for superheat. Liquid line for subcooling. So if we have a gauge right here, if we have our 2 gauge here, so this is the low side, okay? And we are doing 410A. So all the way to 150, 125 PSI. So if we have 125 PSI and you look at the saturation, like the Mason says, we have almost 40 degrees, right? 40 degrees, right? And you get the line temp, which is right here, a little bit far, right here probably, like a feet away from compressor. That's what you want to get the line temp, right? So if you have a suction line here, you get a temp right here. Your clamp is going to be right here, okay? And if you're reading, here we have 40 degree, right? And on that things, we have 50 on the suction, or 48 or 50. So what that tells you?
10 degrees.
Huh?
10.
Say that again, loud.
10 degrees superheat.
10 degrees superheat. What is a 10 degree? Is good or bad? It's good, right? The charge is complete. So how about if we have my low side is 20 and my line temp is 70 degree, then our superheat is gonna be 50, right? What that tells you? It's low on refrigerant, right? You gotta add it. You gotta add it slowly, not dump so much in there. Always use your scale. If you wanna dump the refrigerant, you know how much you put it inside the system, right? In case if you wanna get rid of it, you know how much you put it in there. Like everybody has the scales, right? So how to use the scales? So you just when you hook up your gauge here, you put it upside down. That's what we want to do the liquid, right? We don't want to do the gas. And then turn it on. And press it on 0. So now you know how much refrigerant actually you enter into the system, right? So that way you know 2 ounce, 4 ounce, 6 ounce, whatever you put it in there, you know. And you can charge a customer. So any questions so far? No? Okay. We go into the soft cooling bit. This was the superheat.
It'd be beneficial if they would all grab their gauges, maybe and have it in front of them as they're walking.
Yes, it's perfect. You guys have gauges. Everybody has gauges, right? Everybody has gauge, right? Everybody has the vacuum, micron vacuum gauge, right? Everybody has the pump, and the 410A and the scales, right? Most of us, we have it, right? So, can you guys go grab your gauge and come back here quickly?
Please, go grab your gauges.
You need this one.
Are those your gauges? Just take them.
You want me to go get yours?
No.
Is that okay?
Yeah, perfect.
Yeah. look at it so they can see what you're talking about.
He's got texts from me, he's got. But you know what, his phone may be programmed that me and you are the same person. I don't know. Because that being my own number, he may have that stored as me, and when I, it's just a name showing up there on the phone. He may not realize I'm on their flight.
That one.
Oh, you.
Not gonna help me much, but.
Mason, where's your hoses?
They're in the truck, I don't use these, I use digital, so hoses on everything else.
So digital is that's the important thing. If you have a digital, you gotta know subcooling and superheat.
Yeah, it tells
Because that thing is calculated for you.
it just does everything.
Like Roy, you will never learn
Yeah.
because you have a digital page. Oh, you don't need. Okay, subcooling. So subcooling, when we have a TXV, so who can tell me what is TXV? Why we have TXV?
Keep superheating same. Regulate superheat.
So TXV stands for thermal
Expansion valve.
expansion valve, right? What thermal extension valve does, Roy?
Meters the refrigerator.
Metering refrigerant. That's all we have right here is metering refrigerant to the coil, right? So the amount of refrigerant when the coil is starving, actual indoor coil, right? When it's starving for refrigerant, that has a bulb. The bulb is on the suction line. So that bulb is sensing the temp. It tells the TXV when open and then when closed, or partially closed, okay? When the coil, indoor coil is starving for refrigerant, that bulb sending the little bit refrigerant, that's what it has screwed to the top of the line, right? To open or partially open to fully open, to send refrigerant to the coil, right? That's what TXV is metering. Metering refrigerant, that's all it does. So, here is your gauge, right? On the high side. If your gauge reading 200 psi, what do you have on your gauge, Jeremiah? 70 degree, right? So you have 70 degree saturated liquid line, right? So when you use subcooling, where do you hook up your clamp?
On the liquid line.
Everybody knows, right? Where do you hook, Mason?
Liquid line.
Liquid line.
Yeah,
Good job.
I just misspoke earlier, so.
So liquid line. This is very important because we know, but actually we go to the job, there is a, so it can be a callback. People, they think they know they fix it, but actually it's callback. So, and then when you put your clamp on the liquid line, so if you get, your clamp is like 50, right? And your saturated line is 70, it's going to be 20 subcooling. What it tells you? What that tells you?
Overcharge.
Who said?
Overcharge?
Good job. Good job, Jeremiah. it causes overcharge. It's complete opposite than superheat. When the superheat, the higher number it tells you is low on refrigerant, on subcooling is different. The higher number is overcharge. So the lower number is being undercharged. If you was getting like 79 here, it could have been 9, so subcooling, and it was perfect. All subcooling method, we are going to 10, 9 to 10, and the superheat between 8 to 15, right? So just be careful when you go early in the morning, you go to the service call, it's cold. Inside the house is cold, outside is cold. Don't dump refrigerant so quickly because the amount of cold air going to the coil and come back to the system is cold air. So you may not gonna adjust the superheat or subcooling. You gotta use a blanket like Mr. Don provide for all of us. So you gotta use your blanket to reduce some airflow to get the correct charge. Any questions so far?
Change the 79 to a 61. No question.
Exactly.
That is, so that would be nice.
It's gonna be super, yeah.
Yes.
So, any questions so far? Why is so important superheat and subcooling and refrigeration? So the amount of refrigerant you enter into the compressor, it causes lots of problems. The refrigeration, especially 410A, high pressure, right, is a lot different than R22. So if we put even 2 ounces extra in the system, it causes a lot of problems. Eventually in the hot days, in the summertime, our head pressure goes all the way up. It's not going to cool the house. With the high head pressure, the refrigerant comes back to the condenser and going back to the atmosphere from the fan is going to be very hot. It's not going to cool down the refrigerant, right? So, and then the compressor by itself has a winding, right? If we have a common here, start here and run here, right? Too much refrigerant can cause damage to the winding. So sometimes you see the resistance is too high. You gotta look at your charge. So between common and a start to run and run to common, the resistance you see is the higher number sometimes. So between a start and run, what is it? A start, run. So always, right?
Yep.
But a start and run is always bigger than common and run and common and start. That's what the mathematics formula, right? So if we have between common and start, we have 3 ohms, and between common and run, we have 2 ohms. How much should we have here?
1,
5. Because these things, these two add together,
Jeremiah's stuff.
Yeah.
right? So always our start to run is higher than these two, so or equal. So we gotta use our method when we go to customer to see the compressor, what is the winding. Any overcharge, it causes this number to go up and down, because it's winding, right? So we got to make sure we have a good charge in the system. same as factory charge. Don't put too much in there because we think automatically, technician think we put the refrigerant a little bit more is better than less. No, we want to make sure our super is 8 to 15 and subcooling is 9 to 10, always. Always use the method of charge. Any questions so far?
On refrigerant, when you guys talk about contaminated refrigerant, how can you tell?
Contaminated refrigerant, good question,
I do,
Jeremiah.
and it tastes great, but I just,
Very, very good question. Good job. I'm glad you asked. Because most people, we are shy to ask. That's a wonderful question. You hook up your gauge, both sides, right? At the same time, you see the suction line and liquid line is fluctuating, goes up and down. That time you see this air in the system, right? It's going up, down, up, down. It's something in the system. Eventually damage the compressor too, because it's not gonna work. So if you have the moisture in the system, like we find yesterday, me and Vulcan, we find the other day, yesterday, right? We had to take all the refrigerant out, vacuum the, put the factory charging. So you will notice by your gauge, actually your gauge is not gonna be steady, it's going up and down, even suction line. Like if you have some stuff in your suction line. So here is the piston right by the this is the evaporator coil, right? And here is the liquid line, and here is the piston, right? So if the piston is partially plugged, what's that tell you on your gauge? Only affect which ones, high side or low side? Roy?
What's that?
If you have a plugged piston or partially plugged piston, what do you affect on your, what do you see on your gauge?
Starts going into a vacuum, can start going into a vacuum.
You see low suction and like normal low, okay?
Good job. So you see the low suction pressure, always. Nothing to do with the high pressure. Okay? Your suction, even you dump so much refrigerant, people automatically think it's low on refrigerant. I put so much refrigerant in there, it's not going to bring the suction up. So it's going to stay the low because it cannot pass the piston. The refrigerant cannot pass the piston and go to the core. So that's what we have a partially plugged or restricted piston. We got to pump it down and open that piston and put the new piston or clean it. So how to pump it down? Does anybody know how to pump it down? I know the, you guys know, but so Mason, tell me how to pump it down, how to pump down the system.
Just close the king valve on the liquid side.
Liquid side, you
Watch
can,
your gauges until they peg out, until they don't move anymore. Then you got the most you can get into the condenser.
and then what you do after that?
Close the.
Close the suction. Good job. So you hook up your gauge to both, and then like the Mason says, everybody had this valve, right? The valve opener.
Serves right?
Do you have this? This makes very easy than Allen wrench, right? Because it's gonna be quickly. Because compressor is gonna stop on you if you're not quick to close the valve, right? If you close the liquid line, so I always just close this one first.
Right. That's not a good idea.
thanks for the illustration.
So always close this one, and then let's suck it inside the system. Everything has to be sucked in the system. Thank you. So, and then after it's sucked in, you gotta close it so quickly, and then shut off the, compressor. So after you shut the valve, and then you go by the piston, take it out, make sure it's clean, or you can flush the system. That way you know everything is come out, right? All the contaminated, all the stuff. Sometimes we pull the line set through to the crawl space, some stuff, very minor sands or dirt or wood, goes back to the line, and then when they hook it up, turn it back on, all this stuff goes back to the pump, to the piston and plug it. Right?
Can we
So-
back up just a minute? Now, so I don't wanna go past this, cause I know some of you guys in here, I've spoke with them, and Mike, I think you probably spoke with them too. I say pump it down, and I hear the resistance in your voice. It's probably one of the easiest things you can do on there. It just takes time. Anything we've learned in refrigeration, what's the key word? Patience. Everything requires patience, okay? You gotta have a disconnect right next to you. If you don't have a disconnect, then you're gonna end up just pushing the button right here, on here to get it to run. But you gotta have that service wrench, you gotta have your gauges hooked up. When you close this off, and I suggest if you got the disconnect there, just go ahead and use the disconnect. But if you don't have a disconnect, don't be afraid. Push the thing in. You don't have to use your finger. If you're not comfortable with that, you can take a screwdriver, whatever, an insulated one, right?
Yeah.
Okay?
Yeah, preferably.
Put your service wrench over on the liquid side, right? Why do we put it on the liquid side and not on the suction side? Because the suction's gonna suck the shit back into it, okay? Exactly, that's why they call it the suction, so think about that. So, put your service wrench on here, have your gauges so you can see it. I'm gonna be watching on the low side. Push the button in, it's running, okay? I don't have to have the unit inside running at that point, it's perfectly fine. Push it in, close it off, okay? Once it's closed, I'm gonna watch my gauge, and as soon as I see it get down to where it's at 0, put it over on this, close it real quick, let go of the power. If you're using your disconnect, once you see it's closed, pull it off. Do not let that fucking thing run for any length of time with both of those valves closed. You will ruin that compressor, okay? So make sure you have accessibility to the power on. Now once that's closed on there, you have isolated all the refrigerant into the system on there. You can totally open it up. But I'm going to say one thing. If you open a system up, the only reason you should be able to open that system up is if you have a vacuum pump with you on the job. Do not open that system back up and release this unless it's been put under a vacuum. And that's my concern. Because I know some of you, am I wrong?
Oh, no, we've even had to go back on R22 systems where we've done that.
You
And
ruined
believe me,
the
guys,
refrigerant.
it's not easy to take air out of an R22 system without replacing the R22.
You can you?
Well, yeah, me and Steven Christensen did it twice.
Yeah, but
Do you remember how many?
Steve had to put his mouth on the service valve to get that to happen. and
That's why I
just
took
not
him with
common
us.
practice.
That's
Okay.
exactly why I had him there.
Okay, he had to
was good
suck
at
start that thing.
He was sucking it.
Now, this goes into what Ollie's talking about, the non-condensables on there. If we have non-condensables in the system, what causes non-condensables? The fact that we didn't put it in a vacuum before we started. I mean, that's essentially what it is.
Improper vacuum.
Improper vacuum. It's the easiest thing in the world, putting a vacuum on these things. It just requires patience.
Well, yeah, I mean, like
That's
me and
what-
Ollie seen the other day, I mean, you know, we see air and nitrogen in a system a lot, but me and Ollie came across the system the other day was literally, like he said, it was moisture in the system. And that's hard to diagnose, and it caused some real issues, obviously, but, vacuum was important.
Exactly.
Would moisture in the system be something like you gauge up in the rain, or no?
It could, well, all air has moisture in it. I mean, when we're pulling a vacuum, the reason we use a micron gauge is because it tells us the amount of moisture and other contaminants still in the system. So, I mean, if you look out in the air and it looks like air, but it's 28% humidity. So guess what? 28% of that air is water.
So everybody has a micron gauge, right? I know Mike Wheeler has very sensitive to micron gauge. He wants to go 400 micron gauge for every single unit. So everybody has that micron gauge when we go to customer to vacuum the system. We can't just vacuum with 20 minutes vacuum, it's done. How about if he has a you have a leak in the system, you never get vacuum, right? So that's what we are buying this system, which is micron gauge, to make sure at least we have 500 micron every system when we do the vacuum, right? So make sure you purchase this.
Can I add something to
Yes,
that?
sir.
And I don't mean to contradict you
No.
on there, because he's absolutely right. To do this properly, think about it, guys. On our units out there, we're putting 25-year compressors, 35-year compressors. Some manufacturers out there even have a 99-year compressor, which is bullshit because it's prorated depending on the age of the unit when it goes out. But still, we have a 100% replacement guarantee on all of our units that are less than 5 years of age. Some of them have 10-year unit replacements, meaning if the compressor fails twice the first 10 years, you get a whole brand new unit, okay? With those type of guarantees, we have to protect the equipment that we're putting in there. And that's why he's saying you have to have a micron gauge to do it properly. It's got to get down to 500 microns. Now, what if I don't have a micron gauge? Does that mean I should just shit can the whole process and not do it? No, I still want you to put a vacuum on because we're going to provide that vacuum for you. And if you are a true professional and you want to make this your career, you'll invest in the proper tools, right? You'll make sure you have it. But if you don't have it, that's still no excuse to not put a vacuum on, okay? And in those cases,
Yes, sir.
we're no different than the beer can cold guys, but at least we're putting something on there, okay? So letting it run for 20 minutes at that point. But he's absolutely right, you gotta have that. And personally, and Mike, I don't know what your opinion on is, but this is the most durable, affordable one that they make. Is that accurate?
That's why I bought it,
I mean, these are the ones I've always bought, were the field piece ones.
yeah. Yep.
Because you can beat them up and they still work.
Well, right, I mean, what, you got Wheelers, right?
Yeah, this is
And-
what it's a real.
Right, and mine, and they're both the same, so that is a very durable and reliable brand.
And guess what?
As long as you keep the battery up on it.
Yes,
Change battery on it.
Battery lasts like
the one, yeah, I mean, some of you guys, if you use the field piece, I think they're better now, but they used to really be terrible once you attach to your meter.
And guess
They're
what?
delicate.
They were very delicate, you had to clean it with alcohol,
Yeah.
like,
That blue pad and one that had a little,
yeah,
you'll come up
they were very,
And guess what? In this room, Mr. Wheeler has almost 28 years in this field, and he always uses his equipment, vacuum gauge. How many, 30? 35 years. And he never vacuumed the system without his tools. I went to so many calls with him, together we used to, and he always uses that stuff. So that's important. It doesn't matter if you have experience or not, we have to use the tools. So why the vacuum is important these days? Why it wasn't important 20 years ago? We didn't have this stuff 20 years ago. Because the compressor, these days, the factory, they're making compressor differently. Like we talk about, if we have air in the system, what's gonna happen is gonna damage the compressor. So these days, they make the scroll compressor mostly, right? Any factory right now, they produce a scroll compressor than rotary, right? The scroll compressor, what is the advantage? Mason, what is the advantage of a scroll compressor than rotary?
I don't know.
So it's a high efficient, less noise.
okay.
Less noise and high efficient. That's what the two reasons the factory makes this. If you go to any scroll compressor, you see it's running, the fan is running, but you hear the fan, but you don't hear the compressor because it's a scroll. Sometimes you go to the house, you see the compressor noise right away. Even they have a jacket, blanket around the compressor, but you still hear the noise. That thing is rotary. That compressor is rotary. So that rotary compressor makes noise. That's what most factories these days, they go with the scroll because less noise, more efficient. So like I said, this is the inside the rotary. So refrigerant goes inside and compresses very hard and comes out. You can't see it in the rotary. Rotary is like the compressor goes back and forth to make enough compress. It's not efficient. That's what we have a scroll compressor and rotary. So it's very important on the scroll compressor we have a 500 micron when you put on the vacuum. Because if you don't have it, that scroll compressor start making noise. Because a little bit minor, just that air in the system cannot complete the compression on the refrigeration side. That the start makes noise. And the amstra, head pressure, all these things you see. So any question about the vacuum? We all know how to vacuum the system, how to gauge up, superheat, subcooling.
Would you mind just demonstrating at least how to hook up the vacuum with the micron gauge so that everyone can see where the hoses go? Take a picture of this, guys, if you would. If you don't know, there's no shame in this if you don't know. Because if you don't know, now you know.
So if you bring your gauge, Mike, because I'm using my keyboard. Or
I'll call somebody, right?
this is,
I don't use this. You hook that straight to micron gauge. Don't go through your manifold.
Where'd you get that hose, Mike?
That one? From Johnstone.
yeah, they have
Yeah, they
a,
have.
I have two of them, and I do both sides at the same time.
Still only pulls one out.
Yeah, don't go through a manifold. Everything is
Small
easily.
fitting on it. My gauge, well, mine got ripped off.
So why can't you go through the manifold, like mine has a micron gauge built?
All manifolds leak.
Gauge set.
Oh, okay.
Yeah,
The less
and
connections, the
our,
better.
like,
The less.
basically equipped with my
They all
gauge set,
leak.
micron
do
gauge,
you have a micron gauge here?
seal detector.
But I'm good at everyone.
Anyway,
So you have a
but it's a
micron.
solid 4 gauge hose all the way
And that
through.
micron gauge
I
was an
put the big
experiment.
side to put my
Really?
I talked to the field piece guy. It works, but it was just an experiment.
I mean, I
You
had a
can,
little
you can even,
fitting,
actually, this is
so it
just
doesn't
very
go
good.
well.
Put two rubbers and put it like here.
Okay, guys, let's make it, if you would stand off to the side so that the people at home can see what you've got going on. Thank you. Now, real quick, Ollie, before you hook that one up like that, because I don't think everyone has that hose. If all I have
It don't,
Yeah,
it
get-
don't.
is a
Just
three
get a 3-gauge
hose,
hose.
a
There you go.
three hose
Yeah.
gauge set. How am I gonna hook this up with just a
Jeremiah.
3 hose gauge set?
So if you have a 3 gauge hose, you should have a T, so that the middle port right here, it goes to your vacuum pump, right? It goes to the vacuum pump, the middle hose, which is yellow. And these two, it goes to the liquid line and suction. So we have to have a T between your micron gauge and the vacuum pump. So we don't have a T right now to put it on.
What if you don't have?
So actually here says we need one more gauge.
Jimmy rig. Guys, part of our trade is adapting and overcome. What happens if I don't have the T?
Make something else.
Another hole.
There's another way that I used to do it. If I didn't have it,
Goes right here.
yeah, put that up underneath on there, if I had to. Well, you still keep this one on. Hey, guys, you can pull a vacuum from one side, it just means it's gonna take longer. So, what I'll usually do, make sure that's closed off, and then just take this guy and put it right there. Don't let things stop you from being able to make it work, right?
Right,
A
exactly.
little bit longer.
It's gonna take a lot longer. You need to buy other hoses and you need to make sure you get a T, but if you don't have one, this will work.
Yeah.
By putting this guy right up underneath here, won't it? That's perfectly acceptable. It's just gonna take you longer to do it. The ideal scenario is you get the big hose, hook it up off of the vacuum pump, up to the middle port here, and then you have the extra hose that way. But don't let that stop you from not being able to do it, okay?
Or if you have another hose, you can put it right here and here. and hook it up, very easy. So you see the 500 micron gauge here, that's enough.
Now, I know I stopped you in the middle of that, but I just wanted to demonstrate, you don't have to have that T on there, but
Yeah.
go ahead and hook it up the way you were going to, so that it can see how to get that thing hooked up if you have everything that you need.
So if you have a T or another hose, I usually hook it up to my load side, my micron gauge, right, Mike? You recommend that too, right?
I do.
So even right here, or right by the yellow, either way, it's just to pull the vacuum, it shows you, right? So if you have another hose, so just like the T and another one comes right here. So that way it can suck from the hose line instead of only one side. So it's going to be a lot faster. So either way you have a T between these two, it's going to work. It's going to pull the vacuum. So, and then you see the number right here. And then make sure your vacuum pump, the oil level, like the factory says, not too high, not too less. If it's too high and the smoke goes all over the customer house, right? Because it's burning the oil inside the compressor.
Works better now.
Yes, sir.
Out the back.
So with the vacuum pump, you just add oil when you need it, you know?
Yes, you
keep
see
going.
the side glass here? There's a side glass. If you don't see the oil here, you just slowly add oil in there until you see the
Right.
oil on the
What,
side
what he
glass.
was getting at was change your oil.
Yeah, how often should you change your oil, Ollie?
Every 4 or 5 vacuum you do, every 4 or 5 system.
Every clean.
Yes, you have to have it clean. If you have a vacuum pump like Mr. Wheeler has, you gotta use that more often. They purchased like $800 vacuum pump. So if you have the same vacuum pump I have, so I basically change it every 4 system I do the vacuum. Very easy.
You can't change that oil enough, guys, and I guarantee it's a night and day difference. You take one you haven't changed it in a week, and then try to do a vacuum, stop in the middle of it, change the oil on it, you'll notice you'll cut that time back by 75%.
So here is right here, you open it, all the oil comes out, and put it back and add oil into it. So very easy to change the oil on that vacuum pump. So, any question? Very, very quick. When you walk to the house today and nothing's running, right? The first you think, what is it? You go directly to the problem. I want to walk you to the problem so quickly. Okay? You go to the house, the customer says nothing running. What's that mean? What tells you? Huh?
No power.
What power?
There's no.
Low voltage or high voltage?
Both.
No.
Could be.
So,
I check both. Alright.
when you go to the customer, first thing before you touch anything, you go to the furnace, right? This is the most problem we had. Like recently, we used, technician thought maybe it's a transformer, change the transformer, same problem, because of very simple things. So when you walk to the customer, nothing works. So you just look at the safety switch, SOS switch, right by the coil. Just pick it up, see if there is oil or water in there or not. If there is a water in there, what's happening is anybody knows how to wire the safety switch in the just regular furnace or air handler, right? We have two switches. If you have a condensation pump, and we have a SOS switch right here. 2 wire here, 2 wire here, red wire here. Red and common to the board, right? How do we wire them up? As a series. So So it goes to the thermostat and right there, right? So if SOS switch is full of water, what's gonna happen? Because they're normally closed, right? They're normally closed circuit. So if the things has water in there, right? And the float comes up and disconnect everything, is gonna be normally open, right? It's not gonna bring the voltage back to the system. So nothing shuts off everything. Even no heat, no fan, nothing works. Because we directly put it on red. We tie it up to the red, right? So this is the first trick. When you walk to the customer and nothing works, always look at the pump and the SOS, if you have a pump, and SOS switch. For manufacturing air handler, usually we have a halfway block on that secondary. This is the primary, this is the secondary drain, right? So when manufacturing air handler, we have to have halfway block here because they both, the regular system, usually the drain, the primary drain is lower than secondary, right? On manufacturing is not, it's both on the same path, right? So the water goes to here and goes to here too. We have to have a halfway block here behind that hole, so to block the water, and water goes bypass this switch and goes to primary. If the primary is plugged or P-trap or something, goes back to the secondary and shuts off. So I recommend you to look at the, every call you go, make sure there is in right direction. I mean, sometimes it's the backwards. The SOS switch on primary, primary on secondary, because we are on hurry or something, the installer, they put it backwards. So, any questions so far? Any interruption for the high voltage interruption on the compressor cause the compressor to reverse. This is the common problem, probably every day we walk through this problem, right, Mike?
Yes,
Almost every day.
yes.
The technician calls you and says, hey, my,
Well, the thing we ran into the most is compressors running backwards in the scroll. And that's easily explained. If power's interrupted, a scroll, when it shuts off, the pressures push the scroll plate backwards when power's first shut off. So it's already spinning backwards if you short cycle the scroll. That's why it starts backwards. Because as soon as you shut power off, pressure reverses rotation, and you start power back up, it's already reversed, it's just gonna run like it's spinning. Anyway, and overcharge. So the unit, you guys show up and it won't start. That's what we've seen a lot of recently.
Is that doing on TXVs and fixed?
Yes,
Both of them?
yes, we've had problems on both. Wheeler came across one that was actually a mechanical failure, and was able to dump the charge, get it started, reintroduce charge, and it, was working probably 70%. Yeah, but it was running 70% capacity. I mean, we were able to actually start up a locked compressor just by dumping charge. That was able to dislodge the scroll plate that had broke, the tip that had broke, dislodged and started back up. Now, we could see it, we left it because it's a warranty compressor and it's
I
cool in
think
the
we had
house.
another one the other day that was doing the same thing. We evacuated it and was able to get it started on
Right.
another one, wasn't it?
Right, and we did the same thing on an old one that I think Western had condemned.
Yeah.
A 12-year-old unit that Western said this is toast, it can't be ever operated again, and we were able to remove the charge,
Which take the pressure off of it.
took the pressure off of it, started that compressor up, charged the unit, and we'll probably sell them a new unit instead of Western, just because we were honest and went that extra step to say, actually, your compressor's damaged, but no, it's not bad. So anyway, go ahead.
we have 10 more minutes left. So I'm going to talk about the compressor very quickly because it's a common problem, everyday problem, especially in hot days, right? When it was hot day last week, we went over like 10, compressor, rotation was all the way around. It was working backwards. So that's a scroll compressor, right? Underneath the compressor, there is an oil to lubricate the bearing right here. All the bearing and mechanical things, right? Around the compressor is the winding, like we went over winding. And this is the shaft right here, and the plate, which is 2 plates, is just rubbing like that. That causes the refrigerant goes from inside and compress the refrigerant and send it to the system, right? So what we need to know, if we walk to the problem, you say it's compressor reverse. The first thing you know when it's reversed, what is it? What do you check, Mr. Roy? What do you check?
The amp draw.
Amstra. Perfect. Amstra. So what's going to affect Amstra? What's going to do that Amstra? It goes up or goes down?
Goes up,
Goes down.
down.
The Amstra is going to go down. So the normal Amstra for a scroll compressor is 5 to 7, right? If your compressor is going to reverse, it's going to drop 1.5 to 2.7 amps. Not going to go higher than this. If your compressor amps drop is 5 or 4, it means okay, it's not reverse. The problem is somewhere else, right? So we want to make sure the amstra is the key to know the compressor is reversed or not. The first,
What are your pressures doing when it's running in reverse?
the pressure, the both high side and low side is gonna go down. It's gonna be low. Because people think it's low refrigerant, the dump refrigerant is not gonna come up because the compressor is reversed. So the low side and high side, it comes down. It's very low. So
So
it's
low amp draw and low pressure.
low pressure, low amstra, right? I think Greg went to one of them just last week. He diagnosed it and we got it fixed. So
I think mine was high pressure though. My suction was like 200, and then my high side was over.
that wasn't reverse. That thing you went there, it wasn't reverse. It was overcharged. Remember we went over that compressor. It wasn't reversed because when I asked you, you said the amstra was 4, and that was overcharged. And a scroll compressor is get overcharged, is not gonna run. It's not gonna bring the compressor on. It's gonna come on for a second and shuts off. So the compressor reverse the low pressure, suction and liquid, always. So how to fix it? How to fix the reverse compressor? The first of all, you gotta disconnect the voltage. High voltage, right? So here is the basic schematic for compressor, right? Here is compressor, here is the contactor, L1, L2. Here is our capacitor, is a common, herb, and fan, right? Here is T1, T2. Contactor. So, compressor, we talk about it, is a common, just one pin connection on the top. Right? So we need to have common from the capacitor to common, and here to here, and the fan, and another to T1, and the run, and the common. Right? That's a basic wiring for the compressor. So if you see the compressor in reverse, I want you to take all this wire off the capacitor, off the contactor, 3 wires off. No involved with high voltage. I know you shut the disconnector down, you shut it off, but take that wire off. Let the resistance run away from the winding inside the compressor. Because if it's connected to the capacitor, it's not going to help. So take all the wire off. And then leave it, if you have a garden hose, just put the water, cold water, for 10 minutes, right above the compressor. You have to remove the fan. Remove the fan and dump the water on the compressor. After 10-15 minutes, put it back. Put all the wires back and try to turn it back on again. It's gonna reverse the compressor. It's gonna go to the right rotation.
I see, why wouldn't I just pour the hose through the fan or the compressor while I gotta take?
You can, but it's just, it get to the blade. The blade's gonna, when you hit the water, the blade's gonna go on. It's not gonna put the, water. You can just pick it up and put it there, that's fine. But if you can do it, that's fine. That's the idea to just cool down the compressor, anyhow you can. So, it's gonna reverse it for 15 minutes. Why the compressor get reversed? Because a start and run inside the winding, it get reversed. That's what the right here on the compressor, it get the things get reversed. Instead of going right direction, it goes the backwards. Because the run and the start, that's what we want to cool down the winding, right? To send the right voltage. If didn't reverse, the last things you can do, the very last things, I need to talk to Mr. Cox, and I come with another solution to reverse the compressor. Without talking to Mr. Don and Mike and Mr. Jeff, I can't advise you to do that. Next week, probably next training, we have a solution if it's still not working. If the still compressor after you cool down is not working, is reversed still, and then we go to that solution. I need to talk to. Yes, sir.
Can you just switch line 1 and line 2 on the compressor? Just.
It doesn't happen. It's just a one-phase compressor. It's not two-phase, right? The one phase is 240, right? Just a one-phase compressor. This compressor is only one phase. So if the boss is 110, right?
Yeah.
If you change it, it's not gonna do anything, right? It's not gonna change. The only things change it, the start. That's what I'm gonna tell you guys next meeting. So we have to do something to the start to reverse the compressor. So next training we have that answer how to, if we did all these things, it didn't reverse, and then we go to the next system.
That's tomorrow.
That's tomorrow
Yeah, we're gonna continue this tomorrow and on Thursday.
and on Thursday. So hopefully the knowledge, I know, I learn every day from all of you guys. It's a teamwork. It's a hot day. Our brain is not gonna work very good in hot days, 100 degree. We always use the team. I always use Mr. Don, Mr. Mike, and other members to find the problem. So is not. Don't be shy. If I have a question, I ask you guys. If you have a question, I'm very glad Jeremiah asked me a lot of questions. He does a wonderful job. He still bring the good questions. I hope everybody bring the question. If you have, don't put it in your mind. Don't walk from this door without asking. Because knowledge is the most important. Every day we learn. We increase our knowledge. We do better in future, the customers. So thank you so much everybody for being here. And I wish you good luck.
Thanks, guys. Thank you, Ollie. Have a wonderful day.
So, this,